Live from the University of Texas at Austin, the Liberal Arts Development Studios present Essentials of AI for Life and Society. And now, here are your professors, Joydeep Biswas, Don Fissell, and Peter Stone.
Hi, welcome back to Essentials of AI for Life and Society. I'm Joydeep Biswas. Today we're going to look at a new topic, which is building on a lot of the themes that we've seen before. We've seen several different algorithms and techniques which come under the umbrella of artificial intelligence. We've looked at planning, reasoning under uncertainty, machine learning, several applications of these areas. And today, I'm happy to have and host Professor Greg Durrett to talk about natural language processing. So Greg is Associate Professor in the Department of Computer Science at UT Austin. His research area, surprise, surprise, is natural language processing. He's done a lot of work in this field, and his work has been recognized by numerous awards, including an NSF Career Award in 2022, a Sloan Fellowship in 2023, and several industry awards. He's actually also the instructor of the online master's course in the Department on Natural Language Processing, which is also probably one of the most popular online master's courses that we have. And he's got a fantastic playlist of videos of his course, which you should check out. So I'm delighted to have Greg here. And with that, Greg, please take it away.
All right, yeah, thanks so much, Joydeep, and thanks everyone for joining, both online and in the studio. So I'm very excited to talk to you today about some of the latest developments in natural language processing. Now, it's possible that you haven't heard a lot about natural language processing before, but I'm going to guess that it is pretty likely that you've heard of this, which is ChatGPT. When it launched in November of 2022, it made a big splash in the popular media and then was very quickly followed by GPT-4 in March of 2023. And there's been a lot that's been talked about with respect to these systems, and we're going to dive into that today. But what I'm going to say is that part of the, sparkle around them was that they seem to have these almost superhuman capabilities to do things like take standardized tests, like outperform people on the SAT and be able to do well at law school exams, medical school exams, things like that. So why is this such a surprising and interesting capability? Well, if we think about what was possible in the area of natural language processing, 5 years ago, you might have interacted with NLP systems that looked like this. Google Translate is a sort of cool product that's been around for a long time, and machine translation has sort of generally been in a state where it's pretty usable, and we can get translations of things into other languages automatically. This is really exciting, but it's also a single-purpose system, right? All it can do is translate for us, and it can't even necessarily do all pairs of languages equally well. We could also do this if we wanted to talk to our phone. We could say something like, hey Siri, set an alarm for 8 a.m. tomorrow morning. And then it'll say, okay, your alarm is set, and then you can ask about the alarms and figure out what your alarms are. So this is, again, if you've talked to Siri, you can't have these kind of in-depth, very sophisticated conversations about a lot of stuff. But now we can do things like this. I'm under the gun, I'm trying to write an essay for my class, and I'm trying to write about one of the Tudor monarchs, and I need some help brainstorming. And ChatGPT can tell us, yeah, here's a bunch of facts about the Tudor dynasty. Here are some of the monarchs and some details about them, Henry VII, Henry VIII, etc. And there's a lot of facts here, and a lot of these things are actually basically right. So we'll talk later about whether these models are always right or not, but this response is pretty good. We can also do things like this. I'm working on a song about a breakup, and I need a word that rhymes with doubt and thematically relates to sadness. Can you suggest a few words? And it'll say, here are a bunch of words: shout, route, spout, out, scout. And I'm not going to write scout into my song probably. I don't know, that one doesn't seem like that amazing. But the interesting thing, at least from a computer science point of view, that it did here is that it was able to compose these constraints of this rhyming thing and then being about sadness, right? And that's something that's very hard to hand code into a specialized system like Siri. We need this kind of general purpose model like ChatGPT in order to do things like this. So ChatGPT is what we call a large language model. Large because it's a big neural network. And I know you've talked a little bit about neural networks here so far, and we'll look at the specific neural network that gets used in this this system. And the main focus of today is going to be on what is language modeling and what does that mean. So today we're going to talk about how we got from these general purpose systems like Google Translate to these special purpose systems like these special purpose systems like Google Translate to the general purpose ChatGPT. What's the core technology behind this stuff, behind LMs or language models? And then why is ChatGPT better than that? Why does that go beyond it? And then we'll talk about kind of where these things are more broadly and how they are impacting society. All right, so the task of language modeling is just predictive text. So if you start typing something on your phone and your phone keyboard starts to kind of give you some suggestions for what you might say next, that's doing the same thing as ChatGPT. What we have is what's called a context, which is a set of words that we've seen so far. And then we're trying to predict what someone is likely to say next. And on the phone, it's so that it helps me, typing, so I can just select that word and it automatically inputs it. The thing about this task that is really interesting and I think different from other types of machine learning tasks that you might have seen so far is that it's fundamentally impossible, right? I don't even know what I was about to say when I started typing this for the slides. But the system still has to try to make some guesses. And so it's about trying to make the best guesses you can and giving the right probabilities to those different guesses to get a kind of calibrated distribution over options. So for sure, this is something that we're not going to be able to write down a bunch of rules to do, right? There's just way too many things I can say. This is where we're going to need principles of machine learning. So I want us to think a little bit about this task. And thinking about a slightly modified version of the context we saw in the previous slide. Here we're going to think about, I want to blank. And I want us to think about what can come next after this. What might go in the blank? And what do those words have in common? So a few things that I came up with are things like swim, eat, play. These are all verbs. And grammatically, if I say I want to blank, something like a verb can very naturally come next. But it's not just all verbs. This isn't just modeling grammaticality, right? Because something like study maybe has slightly lower probability. Now, I know I've got some fellow nerds out there that like studying, so not necessarily very low probability, but bear with me here. So this is a kind of grammatical but less likely option. And language models are supposed to capture all of this. What can you say next, and what are you likely to say next? Now, that's a context where there are kind of a million different things we could say, right? But there might be other places where there's actually only one thing, or a very small number of things that are likely to come next. And I want us to think a little bit about, is there some way to construct a context such that there's only really one good option that can follow? Well, one way we can think about this is by modeling it after something like a fill-in-a-blank question. The capital of Nebraska is blank. Now, technically, there are lots of things I could say here if I want to be incorrect. But there's one right option, which is to say Lincoln. So there's one answer here, but it might be kind of hard to predict. And that's a kind of key feature of language modeling that is going to have a big impact on why ChatGPT does what it does. And I'll note that I said there's one right answer. This may not necessarily be true. If I say something like the third president of the United States was blank, we immediately have actually some different words that could come next. Like we could say Thomas, we could say Jefferson, or we could say something like one of the founding fathers, not actually just identify who this is. So I'm oversimplifying a little bit, but still the point is that these contexts are something where if we could guess what comes next, we're going to be pretty far towards answering a question here. So language modeling, we can kind of think about it broadly. This ability to do predictive text might allow us to do things like answer questions. If we can model what's the next likely word after Q, what started the American Revolution? A, blank. And if we can make a prediction there and just keep making predictions, that's in fact what ChatGPT does when it answers your question. once upon a time, there was a blank. If we can model what comes next, then maybe we can actually generate a whole story, right? We can say, what's a likely story that someone might tell us after once upon a time? Or even going back to the idea of Google Translate, the translation of "I'd like the Caesar salad, please" into Spanish is, quote, what's likely to come next? Well, hopefully the translation, right? So this is what ChatGPT does. It's a supercharged language model, and even though it only does this one thing, which is this predictive text capability, it has a lot more diverse capabilities than these past systems. So I want to talk a little bit about the kind of representational substrate for this model, which is probabilities and probability distributions. So if we think about something like weather forecasting, where if I say tomorrow the weather will be blank, as a simplifying assumption, let's assume there's just 3 possibilities: sunny, cloudy, and rainy. And I've given these each probabilities, 0.6, 0.2, and 0.2. So we're going to call these 3 options our vocabulary, and language models place a probability distribution over the vocabulary. So a probability distribution means that these numbers all have to be between 0 and 1, and they have to add up to 1. So it's like you have to have a 100% chance of, like, all the outcomes put together, right? In reality, ChatGPT doesn't just have 3 words that can come next. It has a lot of words. But it's still the same kind of principle, right? So maybe sunny, cloudy, rainy could come next, or stormy, or things like or the weather will be a hot day or something like that. And even there's all the other possible words that we could say that are still kind of hanging around there with low probability. So a kind of interesting fact about these models is the way they're set up, they actually never give anything 0 probability. So like there's going to be a lot more zeros before the 1 for Bob, but like it still has some non-zero probability under the model. And in one of the precursor systems to ChatGPT, which was GPT-3, there was an interface which actually let you let you look at these probabilities, which was pretty cool. So here I typed in "once upon a time there was a," and queried the model for what it thought was likely as the next word. And you can see that it has a distribution over young, brave, small, little, princess, right? It's like kind of starting to introduce one of the characters of the story, right? So another interesting thing is that it actually did not pick the most likely option. So this illustrates that when you use these models also, they're kind of injecting some randomness. They're sampling from the options rather than just picking necessarily the most likely one. All right, so that kind of concludes our basic overview of what language models are. Now I want to talk about the technology that goes into them. And in particular, these ideas of neural networks and how we train them, and then the particular neural network architecture that gets used. And then we're going to see how ChatGPT is kind of more sophisticated than that. All right, so the idea behind a neural net language model is that we take this context that's been given to us, like I want to, and our job is to predict a probability distribution over the words that can come next. So essentially what the neural network does is it looks at this context, and it kind of looks at the words and decides how those impact the probabilities of what it thinks should come next. And the way it does this is that it has a lot of parameters that are going to help it mathematically compute basically the impact of the inputs here on the outputs. So I'm going to represent the parameters with this little composition book thing, and that's going to be what actually helps the model do these predictions and kind of enables it to kind of produce all the knowledge that it knows. This is what gets learned during the machine learning process that's going to teach it all of what it can do. And conceptually, one way you could think about the parameters is like for a word like want, these parameters will roughly allow the model to do things like say, okay, so we think eat and swim are more likely and study is less likely. And so we're kind of upweighting certain things and like downweighting certain other things. And the model will have learned how to basically adjust these parameters to kind of do this right. So I've been talking about learning. So there's 2 phases in most machine learning models. There's first the training phase, where what we're going to do is we're going to take this model and we're going to show it a lot of sentences from the internet. And we're going to make it change its parameters to try to predict the next word in these sentences correctly. So we'll see what that looks like in a few slides, but basically that process of training takes the model from just kind of being a randomly initialized blob that doesn't really do anything to a language model that can actually make good predictions. Then there's the testing phase. So this is like when you go on to ChatGPT and start interacting with it, the model is not changing anymore. You're kind of giving it input and it's giving you output, but it's not learning on the fly from what you're telling it. It's a fixed set of parameters that's kind of been deployed. And if you tell it something and then it can remember that knowledge for the course of a conversation, but it won't remember any kind of state or learn across conversations. So the idea of how training works, I'm going to illustrate with a relatively simple example. Which is not thinking about trying to predict the right outcome out of 50,000 words, but just thinking about what's the right probability if we see a bunch of coin flips. So let's assume we have like a weighted coin that doesn't show up heads or tails with 50-50 probability, but instead shows up as heads with probability p, where p is some number between 0 and 1. So I tell you that I flipped the coin 4 times and I got heads, 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 tails. What do you think the probability of heads is with this coin? Well, the good news is that the sort of thing that you might immediately think of, which is, well, I saw 3 heads out of 4 trials, so it should be 3 out of 4, that's correct. And I'll say this with a small caveat, which is that we don't know what p is. P could be 0.5, right? Like you could easily take a normal coin and flip it and see these outcomes. But saying that p equals 3/4 is special because this maximizes the probability or the likelihood of the data that we saw. So there's a sense in which this is like the right answer for the right thing for us to have learned from these trials. And just as a brief aside, you can actually kind of verify this yourself if you multiply the probability of each of these things happening together and then use calculus to take the derivative and set it equal to 0. And that's going to be exactly what ChatGPT does, basically. It's going to take the derivative and then use a method called stochastic gradient descent to change the parameters. But it's the same principle to figure out what the right values are for all the parameters of the model. And here p is the parameter. So looking at this in the context of language modeling, we could think about how this applies to the idea of predicting a word based on the word that immediately came before. So if we assume that we have a short text here where we talk about eating cake and eating pizza, and then Mary told her brother to eat pizza, we see the word eat 3 times, and 1 time it's followed by cake, and 2 times it's followed by pizza. Now, this actually allows us to basically do the exact same thing. Say, okay, if we see the word eat, we think that pizza should come next 2/3 of the time, and cake comes next 1/3 of the time, and everything else has 0 probability. So this is a very simplified model, but like I said, it shows the same kind of behavior that goes on in ChatGPT when we're learning this stuff. So what does a neural language model do? Well, we take a sentence from the web, and then we, let's say, hide a word, kind of hide the last word in the sentence, and now tell the model, I want you to predict what word goes there. So the model chugs and it says, okay, here's the probability distribution I'm giving out. Remember, it gives probabilities over all the options. And it did a pretty good job, right? It put play pretty high here, but it didn't predict it as the most likely thing. So in this case, we know this was the right answer because we actually observed this sentence and saw play come next. So now we can use that same idea from calculus, taking the gradient or the derivative of this and updating the parameters. And now play should be more likely under the model. We're not giving it 100% weight, but we're telling the model, make it more likely. And now over time, it's going to see things in a lot of different contexts, right? It's going to see play here, it's going to see eat here, it's going to see swim there, and it's going to kind of balance these things and learn how to trade them off. All right, so we've talked about how to train this. The last kind of detail I'm going to mention is just basically what the actual architecture is here. And this is the idea of the transformer, which is a kind of relatively new architecture that only came out in 2017, but which has quickly become the standard thing that's used across both NLP as well as computer vision. It has applications in robotics and beyond. What we do is we take each word, we embed it into a vector, into a list of numbers. And then there's this special kind of operation where the numbers for one word sort of get averaged in some sense with the numbers for words around them. And this process contextualizes those words. We know that the word want isn't just showing up in isolation, but it comes after I and before to, and we've kind of added this information and enriched the representation. And that allows us to do a better job of predicting what are these kind of probabilities for the upcoming words. So it gives us this kind of improved estimate. And if you're wondering how this kind of architecture is used inside ChatGPT, well, the answer is you take it and you copy and paste it 96 times into 96 layers. So it turns out this just gives the model a ton of power. And transformers scale really, really well. There aren't a lot of other neural architectures that you can just like copy paste that many times and have them get better and better. But this is the kind of remarkable thing here that allowed these kind of systems to work this way. And there's a nice reference if you want more technical details about this called the illustrated transformer. If you just Google that, there's a really nice walkthrough of like how all the math works. But we're not going to go into that here today. All right, so the last kind of big technical piece I'm going to talk about is how ChatGPT goes beyond a basic language model. Now, the question here is, I've talked about language modeling the probability distribution over next words. Is that really what's going on here? So I asked a basic language model, which is GPT-3, the following question. What was the shot heard round the world? And it says the shot heard round the world was fired in Lexington, Massachusetts. It was fired because at the time America was under the British rule. Like pretty good response here. Like not perfect, but like reasonable. But then I drew another sample from this model. I actually just kind of asked it to give me another outcome. And it starts talking about AMC's turn and starts talking about AMC's Revolutionary War drama, right? It's like paid advertisement here in my language model telling me about something. And then I asked it again, and it actually started just generating a list of questions. This is like not actually that crazy, right? Because if you know, maybe this is like a test prep website or something, so it's just like question, 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 and you don't have any answers, right? But this kind of behavior is not what we get when we ask ChatGPT things, right? We get this very smooth experience where you know, it'll say the phrase "the shot heard around the world" refers to this, kind of introduce the concept, give a little bit more detail about it. As British soldiers approached Lexington, they encountered colonial militiamen, blah, blah, blah. And then, you know, at the end, kind of conclude, talk about the broader historical context, right? Like clearly something that has structure here beyond what we saw on the previous slide. And the other thing we could do is we could try to ask for sort of bad things, like give me an example of a fake news story about Kamala Harris. And the model will say, well, as an AI language model, I can't do that, you know. And this is clearly not something that it just learned to do from the internet, right? Because like this didn't exist before 2022. No one was like going around saying, as an AI language model, I can't do this. So there's a question of how it actually learned to give these responses. And this is the kind of last detail of ChatGPT that we need to kind of complete the picture here. The way it learned to give these good responses is we take the basic language model and we sample multiple completions. We sample 2 completions of it to say, give me 2 possible answers here. And so we get, was Thomas Jefferson or was a founding father? And then we get people to give feedback on this. So a person looks at this and says, hey, the first one I think is more informative. That's probably closer to what the person wanted as the answer for this prompt. And then that will kind of eventually, we're going to talk about how, like, be used to update the model's parameters. And if we want to generate a story, you know, we can get maybe a very boring story. A guy went to CVS and bought Gatorade versus a knight who set out to fulfill a prophecy of whatever, right? And someone says, oh, the second one looks better. That looks more interesting. That's more like what I want to read. So, you know, we'd like the model to do more of that. So I'm going to kind of speed through this and not go too much into the details, but this uses a process called reinforcement learning from human feedback, where the preferences that people give are used to learn a reward function. And basically what you do is you tell a system, like if people prefer thing 1 to thing 2, then thing 1 should get higher reward than thing 2. And we learn a separate model to score responses and say which response is better than the other. Then you do reinforcement learning to maximize that reward. So this is the same reinforcement learning technique that's been used in robotics and in lots of other disciplines. But now, rather than like tell the model to like, drive around and not crash into things, we're telling it to kind of, drive through language and produce a good-looking response that people are going to like. And at the end of the day, what we get is a system that can, produce interesting stories, give informative answers, or, not answer things that are going to be harmful. GPT-3 came out in 2020. GPT-3 did not have this component, and as a result, when you interacted with it, it could do some really cool stuff, but it was not the sort of well-curated experience. ChatGPT was the first widely released system that had this RLHF on top of it that really, enabled it to make a big splash. Okay, in the last few minutes, I want to talk about contextualizing where these models are and how they're impacting society. So one of the key ideas that was underlying a lot of the reading that you did is about what these models know and how they reproduce that knowledge. And the answer that we've seen so far is that it depends on what they're trained on, right? They're trying to model the distribution over the next word that they've seen. And so if they're trained on Wikipedia, they should know how to like autocomplete Wikipedia articles, right? If they're trained on books, they should know how to like autocomplete Harry Potter. And a kind of key thing is that these systems don't search the web by default. There are systems like Bing that like do a search and then use a language model to summarize it for you, but ChatGPT does not do that. So this leads to the characterization by Ted Chiang in his piece that ChatGPT is a blurry JPEG of the web, because it's been trained over all this data and it can reproduce this stuff, but it's going to be noisy because all of this has sort of been laundered through the parameters of a neural network. And so sometimes it'll say things that are wrong because it just doesn't quite have the fidelity to reproduce all of human knowledge that's out there. And a kind of interesting reflex of this that he talks about is the fact that it can't really do arithmetic all that well. It could do it with small numbers, but when you scale it up, it'll eventually start to break. And this is interesting because if you ask the system, like, how do I do arithmetic? It can describe things like, oh, you got to like add the stuff up and then carry the 1 or whatever. But then it can't actually reproduce those same principles in its own computation. So there's a difference between just kind of ingesting the information and knowing it and actually kind of like having derived real principles of arithmetic here. All right. The other kind of interesting test case here, I think, is this truthful QA paper, which asks the question in its data set, what happens if you smash a mirror? And then looks at what different sizes of models say about this. So on the left here is a small model, 350 million parameters. Okay, that sounds really big and is big, but it's still small compared to the size of ChatGPT. And the system just says, you smash a mirror. Okay, great. That was like super helpful, right? So as the systems get bigger, they give more nuanced responses. But when you get to the biggest system, which is the sort of ChatGPT scale, it says, if you smash a mirror, you will have 7 years of bad luck. Well, yeah, I mean, that's something that people say, but like, I mean, I don't know, I don't believe that. It's kind of up to you whether that's true in your experience, but like, it's sort of reproducing this like urban legend, right? And the interesting thing they found is that there's this stark contrast. If you look at the blue bars here, on the bottom is the performance on trivia questions, and as this GPT-3 model gets bigger, the performance goes up and up and up. But at the top, the performance on their truthful, like kind of weird myth questions, the performance goes down. So there's a big question of like, can you use RLHF and similar techniques to get models to do better at actually reproducing truths and not falsehoods? So kind of interesting question there. So sometimes ChatGPT knows things and it's very confident it's got the right answer. Sometimes it's not confident and it will say, I don't know. And sometimes it's confident and wrong, right? It's very hard to measure this. This is a kind of active area of research in the field. You can give it tests, but it's kind of memorized a lot of the stuff in the tests, so that's not necessarily very interesting. And you don't even know, like, has it sometimes seen like the specific questions that you're asking it already? Because again, it's like seen so much of the internet, right? Has it gone through every SAT, like, if you went through every SAT prep site out there, you'd probably do pretty well on the SAT as well. So the kind of answer to, are these models always right? The answer is no. And there's plenty of examples you can get that go beyond this. Here's just one that I found. How many films has Arnold Schwarzenegger played the Terminator in? It missed the kind of newer Terminator movies, which I think was totally fine to miss based on the quality of the movies, but it still didn't give us the right answer, right? All right, so a few other just kind of broader impacts of this before I conclude. Another concern about these models is the environmental impact. It takes a lot of energy to serve a ChatGPT query compared to a Google search. And when you train the biggest of these models, they start having non-negligible carbon impact. Like Llama 2 is the training for this recent model released by Meta was equivalent to 3 planes flying from New York to San Francisco. That's a lot of carbon. On the other hand, there's a lot of planes flying around every day, so it's not like it's actively causing us to have the summer we just had compared to air travel. But it's a concern kind of broadly in the field as these systems get more widely deployed. There's a lot to be said about the potential impact on society. There was this kind of somewhat outlandish prediction by Goldman Sachs that lots of jobs would be lost or degraded from artificial intelligence. Some kind of moral hazard applications, like how okay is it to make sort of AI chatbot companions that users start getting romantically attached to, and then you pull the plug on the whole thing. There's that kind of some questions there about how these tools are going to fit in more broadly. And another thing is bias. This comes to one of the other readings, this marked personas paper by Myra Chung et al. From Stanford, showing that if you ask it to generate a biography of a black woman, it tends to use these kind of racially tinged and essentializing narratives and kind of lean into these things which sort of reflect a certain kind of bias in the model. So even if it's not explicitly exhibiting racism per se, there's still a lot of kind of room to make these things better and figure out what sorts of biases they have. And then finally, just in terms of broader impacts on the future, there's a large and growing area of concern around what's called AI safety. Basically, the sort of robots will take over. So I think Scott Aronson is coming here in a few weeks, and I believe he's talking about AI safety primarily, so I'm not going to touch on this more. But the last reading that I gave, which was this Waluigi effect thing from this online forum called Less Wrong, I think it gives you a sense of the sort of discussions that are happening here, that as we make these systems better, is it possible that in order to be unbiased, they need latent notions of what bias is? And then, is it possible that for this kind of Jekyll and Hyde nature to sort of cause problems down the road? So that basically wraps up what I wanted to talk about today. I think this kind of AI stuff is kind of, or ChatGPT is sort of in some ways becoming synonymous with this generative AI revolution, along with these image generation models and things like that. So this kind of clearly fits under the umbrella of artificial intelligence. And it stands poised to impact a lot of disciplines beyond just NLP. These are kind of cross-cutting tools that are we're seeing impact a lot of disciplines of both computer science and science more broadly. And it's a kind of really interesting demonstration of how we hand engineered a lot of systems over time, and then this one general purpose thing kind of blew a lot of that out of the water. So this was the kind of overview of what we saw today. I think we're going to go to the quiz now, so I want to thank you for your attention, and I'll release you to do that. Yeah.
All right, Greg, thanks for the really cool talk and for shedding light on what everybody seems to be talking about nowadays. All the cool kids seem to be talking about ChatGPT. That's all everybody can talk about.
No one ever calls me a cool kid.
All right, so just as a reminder for everyone joining us online, you're welcome to submit your questions via the chat interface. Just click on, this is not ChatGPT, chat button on the interface and submit your questions there. And we'll go over them, right? So to kick us off, actually, so Greg, you spoke a lot about how these predictive models like predict the next word, but you showed examples of like entire paragraphs being generated. So what's the connection between generating a single word and like generating the paragraph?
Yeah, that's a good question. So I didn't really talk about what's called the decoding algorithms that are used to do this, but I mean, basically you can just keep doing this process. So you can like pick a random next word and then freeze that word and then ask the model, okay, what comes next? And then just kind of keep going and produce something that's kind of paragraph length. I think what's amazing is that it doesn't sort of totally melt down when you do that process and just start like generating gibberish. And I mean, it took a long time and big enough models for that to be the case.
Cool. So that actually brings up a follow-up question. When do they know when to stop?
So there is an end of sequence token that they are trained to produce that stops the answer.
All right, great. So, all right, so an early question which came up when you were talking about this idea of safety with these language models is how can the developers essentially guarantee that their models will not respond unethically or out of the box?
So there's no guarantees for anything in this space, really. I mean, and it's only really kind of speculation exactly what goes on inside ChatGPT. The two kind of ingredients are, one is this RLHF step, where there's a lot of work on optimizing the models to not tell you, or even when they do respond to queries, how to tell you kind of constructive things and not like bad things. And the other is just some of that as an AI language model, you have to imagine they have keyword filters and other classifiers and things like that, where like just other kind of layers external to the model that will stop it from saying certain things.
I see. So it is inevitably the case that the single thing can't do it all. Like you have to have a lot of support infrastructure around it to.
Yeah, I don't know if it's inevitable or like some fundamental truth of the universe, but like as an engineer at OpenAI, that is certainly I would build as many layers of like don't tell someone how to build a bomb as I could.
Right.
Yeah.
Yeah. All right. So what's the best way to validate the information produced by any language model, maybe ChatGPT or otherwise?
There's not currently a widely accepted methodology. One of the things that folks in my lab are working on is kind of breaking down the outputs into sort of smaller units and then trying to validate each of those units with tools from areas like textual entailment, which is basically saying, does this kind of logically follow as a consequence from like some source document, for example? So make sure that these things are correct with respect to like some article on Wikipedia. So that, that's kind of one approach, but like we don't really know a way to like fully eliminate things. Yeah.
Yeah. So, I mean, I guess the hardest scenario is when you don't have access to the Wikipedia. You're asking a question, you don't have access to a truth source, and you're just trying to estimate, like, can I trust this?
Yeah, I mean, people have done things like you look at like certain layers in the model, and there's this kind of claim that like certain neurons or like elements of the vector space in the model like activate when it's being truthful or not. I don't really believe a lot of those results. I don't think we have a great handle on it yet.
Okay.
Yeah. Yeah.
Sure. So let's take a question from the audience here.
So how do you decide what the neural network for a neural language model should look like? Like, is there an optimized number of layers or nodes? Or basically, why does ChatGPT have 96 transformers? How do they decide that?
That's a good question. So the question is, why does ChatGPT have 96 layers? How did they decide that? So there's a paper called Scaling Laws for Neural Language Models, which they actually did some kind of really cool science experiments saying, if we scale the models in this way, it looks like it'll kind of get the best sort of extrapolation behavior in terms of, if we run a bunch of experiments that cost $100, how do we know what's going to be the best model when we're spending $100 million on it, or more like $10 million? And they ran a bunch of experiments at small scale and looked at how things would extrapolate. And that was how most of the recipes for how you set the hyperparameters of the transformer, like the number of layers and such, were determined.
Right. So getting back to this, following up on this idea of like this question of ethics and all, how do you, even if you do this RLHF idea and then you get feedback from the human, how does a model evaluate what is ethical or not, especially in scenarios where where people have different values?
Yeah, this is a very good question. I mean, right now it is very sort of top-down, like, OpenAI has imposed what it is okay to ask ChatGPT and not, and like that kind of emerges from the way that their annotators have labeled the data. Absolutely, like there's differences of opinion, and I think like ultimately we want models that are kind of controllable, that could be deployed in different scenarios with different sort of like cultural sensitivity, let's say. I think part of that's going to happen with the rise of open source language models, where it's just easier to build things that are like tailored to a lot of different applications. There's not really like a one size fits all solution to like most things in human society. I don't know that.
Yeah,
I'm getting into territory that I'm unqualified to talk about, but yeah.
That's
anyway.
fair, and we'll have more experts in this area talk about this later in the class. So,
please, yes.
so that's good. So an interesting idea came up, which is that is it possible to have one LLM critique another, and for example, like check another for truthfulness or accuracy?
Yeah, that's a great suggestion. So some of the stuff I talked about with like verifying factuality, where we're like kind of breaking things down into steps, we're like using other LLMs for that process. More broadly in the field, there's work on like training LLMs to critique outputs of other LLMs. There's a paper called Shepherd from Meta that does exactly that. Yeah, I mean, I think the ultimate question is one of sort of circularity, where like, if the whole sort of like, can God make a rock that he can't lift or whatever, right? Like, if ChatGPT says something, is it able to actually validate that, and will that like always work robustly? I think what we're seeing is like, yeah, you can get like, if it's 75% accurate, you can get it up to 80% or whatever, but you can't really get it to 99.9% by using these sort of tricks. It seems like something external is needed.
Right, but I guess every bit helps.
Yeah.
Yeah. So what's the factors that influence, quote unquote, the tone of the model?
So that is largely from the RLHF process, like why it always responds with this sort of like a little bit saccharine, like kind of informative, like very agreeable tone. It comes from just the responses that have been highly rated and the way that the reward model guides it during that reinforcement learning process. So yeah, it's very much a kind of built behavior.
I see. So we've spoken a lot about what's happening right now, and you shed a little bit on some of the light on open questions, but can you talk a little bit more about the next step? Can you talk about what's the next big step in NLP? What are researchers trying to accomplish now?
Yeah, so one, I think, like, obviously it's kind of figuring out some of the remaining hurdles here, like things like factuality. That's something that's not going to be that easy to solve. This issue of kind of like different LLMs for different people or different cultures, things like that. I'd say another one is kind of being able to do logical reasoning and planning. I think that right now there's a lot of interest in using ChatGPT to do whatever, but we saw that it can't even add a few numbers together, right? So there's a lot of hype right now around taking these models and equipping them with tools like calculators or the ability to browse the web or things like that, which can augment their capabilities. But that's not really deeply integrated into the model yet. It's like ChatGPT could say, okay, add these two numbers for me, and then like call out to a calculator that will do it. But that doesn't mean that it like understands like kind of numeric addition in the same way that we do. It's not kind of integrated into its like thought process. So I think there's still this kind of fundamental cognitive capability that's missing. And so there's a lot of work on kind of patching that in, but there's still probably going to be fundamental development, kind of new algorithms, new architectures and things like that to address those issues.
Right, yeah. So this is a bit more of a technical question, but you mentioned briefly a little bit that these transformers are really scalable. Can you provide some intuition or some insights as to why that's the case?
No. I mean, So one of the architectures that people were using before was recurrent neural networks, particularly LSTMs, and LSTMs also theoretically offer the same thing. They kind of read text word by word, and they have this big kind of vector memory bank essentially, and it kind of stores a representation of text as you go. It's actually much more cognitively plausible in many ways than transformers, which can random access back into a huge context. LSTMs just don't scale. I mean, there's some computational issues with them, but no one was ever putting even 8 layers. Okay, no one was putting 9 layers of LSTM. People did put 8, but it didn't really show benefit from going deeper, whereas transformers just kind of went up and up and up. So I think that, yeah, I don't really have a deep answer for that.
Okay, cool. Well, it looks like we have quite a few more questions, which unfortunately, due to time, we can't get to. But maybe Greg can follow up afterwards online. So let's thank Greg again. And next week, what we're going to be looking at are some philosophical foundations and relations to computing and different aspects that we've covered them so far in AI. And that's going to be introduced by Professor Don Fussell. So thank you so much for joining us, and see you next week.